Oh no, this stuff's kind of boofy. This is string theory. You gotta spray him in the face and then say string theory.
Oh, Mitch! Oh!
What's up, guys? This is Dominic, and this is Tyler.
What's up, guys? This is Tyler, and we're doing,
And I'm Dominic.
and we're doing,
String theory. Tyler, what is string theory?
well, Dom, string theory is a cosmological theory based on the existence of cosmic strings.
Wow. Or is it?
Yes, it is.
So why do we need it? Well, Tyler, to answer that question, string theory is the next step in our growing understanding of the universe. We don't know everything about subatomic particles, but we use string theory to explain it. Tyler, why don't you tell us about some of the weird things that come from string theory?
Well, there are multiple string theories, such as the bosonic string theory, which has 26 dimensions. There's also the superstring theory that has 10 dimensions.
Wow. That's nuts.
So where does string theory come from?
Well, Tyler, string theory's been around for about 30 years. In 1974, John H. Schwarz and Joel Shirk independently studied the boson-like patterns of string vibration, which led to the development of string theory.
Well, it's a good thing we have people who are curious enough to study these topics.
Exactly. We have a lot of people asking questions like, why are we here? Where did the world come from? And what is the world made of? This is why string theory is useful. We use it to understand the universe. Well, Tyler, how does string theory help answer these questions we have?
Well, we know that atoms are made of subatomic particles, such as neutrons, protons, and electrons. But we can actually go smaller than that, into gluons and quarks. But even smaller than that is strings.
There are 12 basic building blocks of the standard model. 6 of these are quarks. They go by up, down, charm, strange, bottom, and top. A proton is made up of 2 up quarks and 1 down quark. The other 6 blocks are called leptons. These include the electron and 2 of its heavier siblings, the muon and the tauon, as well as 3 neutrinos.
So what are these forces involved in string theory?
There are 4 fundamental forces in the universe. There are gravity, electromagnetism, the weak nuclear force, and the strong nuclear force.
Each of these forces are produced by fundamental particles that act as a carrier force.
In the last few decades, string theory has emerged as the most promising candidate for a microscopic theory of gravity.
It also attempts to provide a complete description of the fundamental structure of our universe. That is why it's sometimes called the theory of everything. The essential idea behind string theory is that all of these different fundamental particles of the standard model are really just different manifestations of one basic object, a string.
How can that be?
Well, for example, we would ordinarily picture an electron, for instance, as a point with no internal structure. A point cannot do anything but move. But if string theory is correct, then under an extremely powerful microscope, we would be able to realize that an electron is not really a point, but a tiny loop of string.
A string can do something aside from moving. It can oscillate different ways. And by the way it oscillates, we can tell what it is, whether it's a photon or a quark, etc.
So, if string theory is correct, the entire world is made up of strings.
Wow.
Perhaps the most remarkable thing about string theory is that such a simple idea works. It is possible to derive the standard model from the theory of strings.
It's important to note that string theory is still just a theory. It's under development, and we can't just say that it is the correct description of nature. There's no direct experimental evidence that string theory is the correct description of nature.
But we do know bits and pieces of it.
You see, that is the whole idea of theoretical physics. We don't know this stuff for sure, but we use it to understand the universe, because we can't know everything about the universe.
You see, a lot of the math checks out, but we can't exactly prove string theory because it's not exactly testable.
You can't see them, but there are strings everywhere. Look at them. See right there, we got one. Right there, too. There. To the side of those rocks, Tyler. Those are strings. Strings in me too. Strings and string cheese. So now we're going to talk about these different strings and how they oscillate differently. Here we have a tachyon, which is a theoretical particle that can travel faster than light. We also have another one that's oscillating a little differently. You can see how these oscillations are affecting our particle, what particle we have. And so that's how we can, we use this visual representation to show each particle. And now you can see this last one here is another oscillation that represents a different particle. These oscillations are really what define the particle. So you can picture this vibrating string. We have these closed or open strings. The ends are attached or not attached. And this can also affect what particle we have. This works exactly like the waves we learned in class. You can see that they have a wavelength, a frequency, and a period. Okay, so you might also be wondering what strings are made of. And while this is a good question, it's hard to answer because strings are really just points. For now, string theory is just a theory, but once we can turn it into facts, we can start looking further into more theories about what strings are actually made of. Note that open strings have polarity. They have a definite front end and a back end, and swapping ends produces a different string. As strings carry charge, one polarity corresponds to a particle. A string walks into a bar with a few friends and orders a beer. The bartender says, "I'm sorry, but we don't serve strings here." The string walks away a little upset and sits down with his friends. A few minutes later, he goes back to the bar and orders a beer. The bartender, looking a little exasperated, says, "I'm sorry, we don't serve strings here." So the string goes back to his table, then he gets an idea. He ties himself in a loop and messes up the top of his hair. Then he walks back up to the bar and orders a beer. The bartender squints at him and says, "Hey, aren't you a string?" And the string says, "Nope, I'm afraid not." That was a lot to take in. String theory is very complex, and we understand that it can be hard to explain, and it can be hard to understand. But we need to know what the world is made of. The world is made of atoms. Atoms are made of protons, neutrons, and electrons. And those are made of quarks and gluons. Quarks and gluons, according to string theory, are made of strings. And these strings have oscillations and frequencies, and that will determine what those particles are.
Now let's not forget that this is all just a theory. Strings are based and formulated on ideas. This does not detract from the importance of string theory. String theory has evolved our basic understanding of the universe. Hey guys, thanks for watching.
Smash that like button.
Now we're going to ask you a few basic questions on Kahoot.